Hi, everyone. Welcome to Open Source GIS from Field to Server, the Ontario and Quebec edition. So we're doing this webinar series. We're sort of trying to split it up across the country. Really, main reason is that we want to be able to show a lot of demo data from across the country. So it's nice to sort of do this webinar multiple times. The majority of the information is the same throughout all the webinars. But again, that demo portion that we're going to give at the end will be specific to Ontario. My name is Cliff Patterson. I'm the CEO and co-owner of Luna Geospatial, and thanks for attending this webinar. And we're just going to dive right in because there is a lot of material that I would like to get through. So here we go. I should also add that the Q&A is open for this webinar. So if you do have a question throughout, please feel free to drop your question there. If I'm able to answer immediately, I will. Otherwise, I will address the questions at the end of the webinar. All right, so what do we do at Luna Geospatial? One of the things that we do the most is consulting and training. We work exclusively with open source GIS, specifically QGIS, PostGIS, Geoserver. We work a lot with remote sensing. We do a lot of training, so both private group sessions as well as public sessions on open source GIS. And we actually offer professional support for open source GIS. So if your organization uses QGIS or PostGIS, we're able to provide that required support for those pieces of software. Now, the other big thing that we do is we develop custom software. So whether you want to develop a custom web GIS or some sort of dashboard or a data portal, anything that's really database driven, that's a complex web application, this is something that we build quite a bit. And it makes up the sort of majority of the business that we do is clients come to us and they have a very specific need. They want to develop something, some sort of web-based mapping platform. We get to develop those, which is a lot of fun. And the other thing that we provide are GIS servers. So these are cloud-based, fully managed servers that allow our clients to use things like Geoserver, PostGIS, MerginMaps, GeoNode, any of these open source GIS packages that we support. We're able to spin these up on our servers. And for these, we provide, of course, all the necessary data backups, support, training. And so we maintain servers now in 3 different countries around the world. And that is just something that is growing exponentially. We serve a growing list of clients from around the world, including a number of universities, telecom companies, nonprofit organizations, different types of environmental organizations, as well as a couple of archaeology firms here in Canada. And we all of our clients use open source GIS in some way. Some of them are using a full server and using a custom web GIS. Others might just be tapping into a few pieces of the puzzle to deal with a certain problem that they have within their development. And so we're here to serve them and provide that support necessary to use these tools. So intended audience, I like to sort of lay this out in case somebody's coming here looking for this being a master course in open source GIS, which it is not. So anyone who is really just interested but might be unfamiliar with open source GIS, this webinar is for you. Any public or private organizations considering migrating to open source GIS, again, this one is for you. But like I said, if you're looking for an advanced course on all things open source GIS, this is not the course for you, but it will definitely point you in the direction to a bunch of different software that's available. So maybe there is some, tidbits that might be of interest if you are already an open source GIS pro. Before we get started, I just want to mention that we do have a newsletter. We don't spam. I don't really like doing that, but I do send, 1 or 2 or 3 newsletters a month, depending on what's going on. If it's a very busy month with a lot of training and stuff that we're offering, we might send a few more or a few webinars. We like to send reminders because we know how busy everybody is. So we don't spam. So if you do sign up for the newsletter, you'll just get probably 1 or 2 or 3 emails a month, just outlining some of the stuff that we're offering in the upcoming 4 weeks. We also do have all of our old webinars on our website. So if you do navigate over to lunageo.com/webinars, You can watch any of our old webinars. We did a series last year called QGIS in the Wild, which was a big success. We're probably going to be doing a few more of those in 2023 as well. And we have a lot of technical webinars that you can go through if you want to learn more about some of these open source GIS tools. All right, so let's get started with the fun. What are the benefits of open source GIS? Well, the first one that most people mention is the cost saving without sacrificing functionality. This is something that I always promote. I say, yes, you're going to save money in terms of licensing, but you're not going to sacrifice anything functionally, right? You're still going to be able to use do all the things that you used to do, but you might use different tools for it. You might press a different button, but the result will be identical. So the nice thing is, of course, no license restrictions. You can put GIS on everybody's desk within your organization, provide them with adequate training, and they'll be able to use this technology. I like specifically that we have quicker and more frequent bug fixes. It's not uncommon to report a bug and then find that in the next release that's been fixed, especially if it's something that's affecting a lot of people. And as I said, with no licensing, that means you can have organization-wide access to GIS. And that's not just, the basic application, but you're going to be able to provide access to even some of the more advanced tools. So whereas maybe in the past, you might have had limits in terms of the licenses for more advanced tools, well, now everybody has access to everything with something like QGIS. So you put QGIS on a desk, you have access to all the tools. There's no sharing of licensing or any of this. I really like that you can customize tools within open source GIS. So the tools that are provided, you're able to customize them or create some sort of custom solution based on a number of different tools, create your own little toolbox within QGIS. These are really neat things that we can do with this technology. There's a large supportive user group for all the software, especially the mature software that we support like QGIS, PostGIS, Geoserver, a lot of users out there to help answer questions. I always say there's more tools. I think that the problem when I'm migrating workflows from proprietary GIS to open source GIS is not really how are we going to replicate this workflow. It's more a question of which tools do we want to use to replicate this workflow? Do we want to do it all in PostGIS? Do we want to do it in Python? Do we want to use R? Do we want to use native QGIS tools? Do we want to create a custom tool? There's so many options there, but that's where we step in and we're able to offer our expertise and offer some support in terms of migrating these workflows. Interoperability, there's often this idea, well, what if I move to open source? Will I still be able to share a shapefile? Yes, you will. You can open up pretty much any file under the sun that can be used within a GIS. You can open it within QGIS. You can write most of them as well and share with your colleagues, even if they're using proprietary GIS. Extensibility is huge. You can actually build your own custom tools. You can build your own plugins or extensions. So if there's money in the kitty to develop these custom tools, you can develop them and install them in your own environment. Enterprise features are huge. I talk a lot in other webinars, and I'll be talking again later on this year about things like multi-user editing. This is huge within an enterprise environment. You want to make sure you're able to monitor editing and grant privileges to different people. This is a core enterprise feature within an open source GIS stack, and it's something that we set up and promote and train people on all the time. Now there is a number 11. There's this huge myth that, well, if you move to open source, there isn't a lot of documentation. That is complete rubbish because all you have to do is navigate to like the QGIS page or the Geoserver page or PostGIS or even GeoNode, and you're going to find a huge stack of documentation. For QGIS alone, we have the training manual, we have the manual itself, and there's a bunch of other more specific manuals on the site as well, including the developer manual, the PyQGIS manual, and so on. Tons of documentation out there. Now, beyond that, there's also, every single YouTube channel out there on GIS will have something on QGIS. There's going to be, it's very rare that you search for a problem and you can't find somebody who's created some content about this, including us. Open source GIS stack. So what does this look like when we set this up for clients? Well, we usually build everything on top of a Linux server, and we use Ubuntu. We have QGIS, which is a powerful desktop application, Postgres, which is one of the top relational database management systems, so comparable to something like MS SQL Server or Oracle. And then we have this powerful feature, the spatial extension for Postgres, which is called PostGIS, and that gives you access to a whole bunch of spatial functions. We'll talk about that shortly. And then we also have Geoserver. So this is the way that it allows you to share geospatial data on the web. And we also have MerginMaps, which is that core application that allows you to sort of take your GIS into the field and collect data and sync it back to the office. And lastly, with this whole stack, one thing that we do most is build these custom web GIS applications. So we're going to be looking, I'll show you a little bit on our application, which we named LunaMap. Which is just sort of like a boilerplate application that allows us to build different apps for clients. So what does this look like when we have it all set up? Well, the central brain of our open source GIS stack is Postgres and PostGIS. So this is our database. All of your vector data lives within the database. And we can serve that out to Geoserver. We can also serve raster data out to Geoserver, but that comes from within the file system. Now, where do we serve this out to? Well, we serve it out to the web. We can use it on GeoNode. We can use Leaflet and create a custom web map application or open layers and do the same. But we can also share the data out to clients. So you can share like a WMS service and protect it with passwords and share it out to a client. Say, here, you now have access to our data via Geoserver. So again, Geoserver is a way for sharing stuff. But we can also do something cool. We can, from QGIS, we can connect to all these standard services. We can connect directly to the database and load spatial layers directly from the DB, or we can access Geoserver, or I should say, we can access Geoserver, and we can load things like aerial photos or any spatial layers that we might share through Geoserver. Now, we also need the file system. We always need the file system. If you're going to be running any type of analysis on, let's say, like a digital elevation model or something, you're not going to be pulling that from Geoserver and doing any type of analysis. You're going to be working with your local file system. So there's always still a need for that local file system, but think of the server as the place where all the good data reside, right? So all that intermediate data, if you're running some sort of analysis, you might do that on your local system, but the end result you're going to load into a database. And the nice thing about QGIS is, of course, you can open it up to all of your staff. So now your staff has access to everything that you've shared through Geoserver, as well as everything that's available within the database. What about MerginMaps? Well, we need to do some field data collection. Your staff specifically need to do field data collection. We want them to be able to collect data using a custom app that we build, and we want that data to eventually make its way back to the database. And Mergin has this nice little app that's called MerginDB Sync that will allow you to sync data from MerginMaps directly back into the database. So we've come full circle, right? So we're able to go out in the field, collect data, sync those data back into the database, and the world is a happy place. So how do we go about implementing this with clients? So the first thing is we configure the server. We configure Geoserver, Postgres, PostGIS, MerginMaps, whatever else that we have to build for the client, we'll do that. And then we go through a phase of database development where we design the schemas, the tables, any type of trigger functions, stored procedures, anything like this. We will set this up for the client, as well as the permission system. Who has access to which layers within the DB? Then we work on data and workflow migration. This is quite a long process where, it really depends on the organization, of course, but we go through what do you do with your current GIS. If you have no current GIS, then it's easy. But if you do have a lot of complex processes, we have to figure out a way of migrating those to the open source stack. So this might just be migrating vector data, easy enough. You have access to those, but we have to migrate those workflows, right? Migrating raster data to the Geoserver, that's going to come with some optimization. Maybe we're going to get a whole whack of Mr. SIDS, yuck. And we're going to optimize those into GeoTIFFs or into COGS and throw them up onto Geoserver. And then we're going to also migrate any ETL scripts that they have. So if there is something that you're pulling in for data from an external service, again, we can incorporate those into the server. We provide full training and documentation. So this is where we'll actually teach courses to staff. So this will be like intro or advanced QGIS, PostGIS, and QGIS and enterprise environment, intro to Geoserver, intro to MerginMaps. But we also provide sysadmin training. So if you do have a sysadmin on staff, we can provide them some instruction on how best to manage the GIS server. And the big thing, workflow documentation. So whatever workflows we migrated to the new system, we document those processes. Next, as we go live, the world is a happy place, and all of your staff are using the open source GIS server and building data and building schemas, and everything is going well. But the really important part about this, in order for this to be a success, is to provide that support. So what we do is provide a support period after, which is ongoing. And you can look at our website. We're very transparent with our pricing for support. We provide a sort of pay-as-you-go structure for support. So, you put some money into it, and we'll just eat away at those hours over time in 15-minute increments. So, desktop software. You can probably guess that QGIS is the one that we're typically using as our open source GIS desktop solution. QGIS comes with hundreds of tools, of course. It's powerful cartography and spatial data management tools. The processing framework is great. It's growing over time. There's always new tools being added to the processing framework, which include both 2D and 3D analysis tools. The nice thing is, of course, no restrictions. You don't have to share licensing for doing some sort of terrain analysis. It's all just available within the application. You can create, edit, manage, and export data in really whatever format you could think of. There's also tons of plugins. I did a webinar on plugins, and I didn't think it was going to be so popular. I did like top 20 plugins. I don't know, I picked the ones that I liked. But that's been like one of the most popular YouTube videos that we put on our site, which is kind of cool. So people love the plugins, and plugins again, that's a way of extending the software, right? It's the extensibility of the software. It comes down to this plugin environment. And of course, if you're more advanced, you can use Python or spatial SQL. We teach courses on spatial SQL, and it's a lot of fun. It's something that I love to do the most. And you can also create custom tools with a graphic modeler. There's a Python console actually integrated within the app. And you can do spatial SQL within the database manager. And there's also additional support for point cloud processing that is coming soon. It's in the current release now, but it'll be on the LTR eventually. Now, another piece of software on the desktop that I'll use occasionally, and I've used this per project, is Saga. Don't judge it by its logo. Saga is actually a really powerful remote sensing and image processing platform. It's installed alongside with QGIS if you're on a Windows environment. I can't speak to Mac because I've never installed QGIS on a Mac. On Linux, it's installed as well. It gives you access to a whole bunch of tools. These tools can actually be used within QGIS as well, or you can use the application on its own. There's a little bit of a learning curve, but you can do both raster and vector analysis. It's easy and effective implementation of spatial algorithms. There are a ton in here. There's some that you would expect from very expensive remote sensing analysis software, but you'll find them in here. It's really nice that there's a modular framework, so you can sort of go into each module and find the different tools that are available. So if you're doing something like image classification, you're going to find a whole bunch of image classification tools here. And so some of these modules include things like terrain analysis, simulation, image classification, geostats, and hydro algorithms. And as I said, it's fully integrated within the QGIS processor toolbox. Sometimes you have to tweak it a bit to get it to work, depending on your installation and where things are actually installed. But once you get it working, it's really nice because then you can actually integrate these tools into your workflow within QGIS. So if you're using something like the graphical modeler, you can use these tools within that process. Another one is GRASS. I've used GRASS a few times when I have to. I've used it for like network analysis, which is really cool. GRASS is incredibly powerful desktop GIS. Again, a little bit of a learning curve to get into it, but once you get into it and understand, it's great. There's 350 core modules for both raster and vector analysis, probably more now. That figure is probably old. The tools work with QGIS. They're integrated directly, and they're really easy to run within the QGIS environment. Again, you can do both vector and raster processing. There's some specialized tools, things like Landsat processing I've used before. I use this to process LiDAR data as well. So there's a couple of really nice tools in there. I've also used it for network analysis. I did a, what was the study? It was on a food deserts years and years ago. And I remember I used the network analysis tools within GRASS in order to pull that one off. It's fully integrated within the QGIS processor toolbox. So again, if you're using something like the graphic modeler, you can pull these tools in and use them. GDAL, I love GDAL, and you should love GDAL too. GDAL is used widely within pretty much every GIS package under the sun. It is the most widely used geospatial library. I think that's true. I feel like it's true. It is actually shipped as it's a command line tool that can be run as well. If you're on a Windows environment, you have the OSGeo4W shell. And this allows you to run commands directly on the command line. Yes, command line. I love using the command line, especially when I'm processing imagery. I'll typically process something that will take, a day or two. And it's nice to run it on the command line because that little flashing cursor means that things are still alive and things are happening. Whereas oftentimes when you're processing large imagery on a desktop application, things will just freeze up and you're left thinking, is this happening? The tools are also available in QGIS. So anytime you do any type of like image export or build overviews or anything like this within QGIS, you're actually triggering GDAL tools. And the same thing with any other desktop GIS platform. So it's a library for reading and writing raster and vector geospatial data formats. Hugely powerful. You can do pretty much anything you could ever imagine with GDAL and OGR tools. And as I said, it's used widely in other GIS software. And as I said, fully integrated within QGIS. So you can actually see, this is from the processing toolbox. You can see that instead of using the native QGIS tools, you can actually use the GDAL tools within QGIS. PDAL is like GDAL, but for point clouds. So it's a point data abstraction library. Is what it stands for. So it translates and manipulates point cloud data. Really nice tool to wrap your brain around if you're going to be working on any type of 3D data. You can create pipelines with readers, filters, writers. You can process LiDAR point clouds. So if you get raw point cloud data, PDAL is your tool. You can load it in and run some of the analysis. Again, anything that is this, this specialized, there's going to be a learning curve. It's not just put it in there, press a button, and it does everything you need. So you're going to have to learn it. You can create DSMs and DTMs. And it is now integrated, as I said previously, into QGIS. So there's the latest release has some PDAL tools for point cloud processing. All right, so let's talk about the server. What are we loading onto the server? So the central brain, as I said, within the servers that we set up is Postgres with the spatial extension PostGIS. So this creates really a spatial database. So everything you could possibly imagine analyzing, especially with vector data, you can do with spatial SQL. It's been in development since about 1996 for Postgres, and PostGIS has been in development since about 2001. So these are very mature pieces of software. This isn't something that was created last year by a guy in his basement. This has been around. It has a steering committee. It is an established piece of software. Spatial SQL, it has hundreds and hundreds of functions. It is incredibly powerful. I use this for the majority of analysis that I do. I'm often using PostGIS. What's nice about storing all your vector data within a database is that it simplifies things like backups and restorations. So we run a daily backup on all of our servers. And we can easily restore these databases individually or the complete server itself and have access to any data. So if there's any accidental deletions, we can always restore this stuff, go in and find the data that we need. One of the things that's nice about this is that we can have a permission system. So we can control who has access to the data and what kind of access they have to those data. We can create things like audit tables and actually monitor any changes that happen within the database. And we can automate through things like trigger functions. So if you have a table and you want to automatically calculate the perimeter or the area of the polygons, you can do this through a trigger function quite easily. Integration with QGIS is extensive. You can do things like save default symbology directly within the database. You have full database management via the database manager. So you can see here what you're looking at is the database manager. You can do things like load tables, import layers, export to a file. You can modify existing tables, and you can run any SQL statement you wish within the SQL window. I like that we can load layers through here as well. This is often how we'll load layers, because we can create schemas and then load layers directly into those schemas, and we can change things too. We can transform the data as we load it. We can do things like convert uppercase fields to lowercase to make the world a happier place. So it's really quite a powerful tool within the environment. Oh yeah, one of the nice things about the database layers too is that when you have data stored within Postgres, you can actually use the native QGIS tools. So this is neat. You can pull a layer from the database, run some analysis using QGIS tools, and actually save the results into the database if you wish. So you don't need to save anything to your local file system. Another nice thing is you're able to save projects. So when you create a project within QGIS, you can save that directly in the database. What does that allow you to do? Well, that allows you to share it within anybody within your organization. Also, we can manage authentication through QGIS, right? So if you're going to allow users to access the database, they're going to have a password, a username, they can log in. And of course, any of the permissions that you establish within the database, those will be established when they connect through QGIS. So if you're only a read-only user within the database, when you connect via QGIS, of course, you're only going to be able to read data in the database. And then there's a lot of really fun tools that you can use, or plugins that connect to PostGIS. The one that I really like is called the Discovery plugin. This allows you to quickly search and zoom any features within a data set. So the Discovery plugin will connect directly to your database. So imagine something like a parcel data set, and you want to search for roll numbers. Well, you could set that up within the app that you're going to search roll numbers, and then just like that, you're going to be able to search roll numbers, and when you find one, click on it, it'll zoom in directly. Another piece of software that we install on our server is Geoserver. So Geoserver has been in development again since 2001, so it's a very mature piece of software. It permits sharing and editing of geospatial data over the internet. It has the ability to connect to a variety of different data sources. So we can pull things like every type of vector data you can imagine. So geopackage, shapefile, whatever it may be. And you can also connect to a variety of different databases. So PostGIS, Oracle, SQL Server, you name it. You can also connect to other services. So if somebody has a WMTS service or a WMS service, and you sort of want to cascade it through your Geoserver, you can do that as well. And I did that with the Ontario imagery. So the government does have a WMTS endpoint. I was able to cascade that through the Geoserver. In terms of raster data, again, whatever you can imagine, we can probably run it. So, in terms of GeoTIFFs, JPEG 2000s, and so on. I prefer working with GeoTIFFs. I just find that zippier and easier to process and just less. It's not a proprietary format, so it's quite easy to work with. So we can serve all these data out through a variety of web services. So we can serve it out through a WFS service or a WMS service, but we can also have a cached imagery service on Geoserver as well. Okay, so what about WebGIS software? Well, Leaflet's one that's been around for many years. And this is basically a JavaScript library that's used to build web mapping applications. And we use it quite a bit at LunaGeo. Depending on what application we're building, we might use Leaflet, and we might use the next one, which I'm going to talk about, which is OpenLayers. And it's not, one thing that's nice is that it's integrated also within QGIS. So if you do want to create like a basic web map application, you can try this QGIS to web plugin, and this will basically export whatever you have on your within your QGIS project, and that it'll export that out to a functional web map application. Open layer is another one, a little bit more advanced than leaflet. So we say there's a lot of features, a lot of more advanced features within open layers. But really it depends on what you're building, right? If you're building something that's just going to be displaying geospatial data, but it's doing a lot of the processing or the advanced processing in the background on the database, really doesn't matter which one you're using, you're just displaying data. Or the results of some sort of analysis that's taking place somewhere else. So this was first released in 2006. Again, it's a JavaScript library for displaying maps on the web. It supports OGC standard formats. So again, anything you can throw at it in terms of WMS, WFS, vector tiles, whatever you need or whatever you need to serve, you can probably do it through open layers. The only thing that the real strength of open layers is that there are a lot of these advanced tools. So some of the stuff that you might have to build custom with something like Leaflet, with open layers, you're going to have a lot of those tools available for you right out of the box. So that's one of its main strengths. Now, GeoNode is another server piece of software that we might install. So it is an open source geospatial content management library. So think of this as your sort of portal that you can share a lot of geospatial data through. It has a simplified it simplifies user management and data access rules. It's really easy just to create a user, grant them permissions, give them access to a certain amount of data, and it actually pulls in, like when you're using GeoNode, it's actually pulling in its own instance of Postgres and PostGIS and Geoserver, and it's sort of a package deal where you have all of this software working nicely together. So you can create both a private and a public portal for sharing geospatial data. So if you have a lot of data that you want to release to the public, but then some that you only want to release to logged in users, you can do that through GeoNode. And that's a really nice feature too, because if you're sharing out geospatial data, you might only want to share it to internal staff. So you might want staff just to be able to access it and load it within QGIS. Nice thing here is that once you fill in all your metadata, I know, but once you fill it out, you're then able to search across all fields. So if you're looking for a specific data set, yes, you can use something like the full text search, and you're going to find it within your system. You can create both data, map, and document catalogs. One of the nice things I like about this is actually being able to serve up documents. So if you do have something that relates to a data set, so you've created this, I don't know, let's say land cover change data set, and then you want to have a document that's actually documenting all of the stuff that you did in order to create this land cover change data set, you can actually upload that as well to the platform. So you're able to share not only geospatial data, but actually other documents like PDFs or Word docs. Very powerful metadata catalog. You're able to enter every bit of information you could possibly imagine about a data set. And you can also enable users to download data in multiple formats from the application. There's also this integrated web GIS and GeoStories function. So there is a map built in directly into GeoNode. And with that, you're able to create a bunch of different maps and share them out on the web, and users can access them and see all this geospatial data that you're sharing. And then you can create something called GeoStories, which allows you to string together a bunch of different maps and to sort of tell a story with geospatial data. One of the things that's really nice about GeoNode is its ability to integrate within QGIS. When you create an instance of GeoNode, you're able to connect to it from QGIS. You're able to load the layers that you have in GeoNode as long as you have permission. You're able to load those into QGIS. So it's really nicely, this integration allows you to sort of have that seamless connection from web to desktop. So you can access the same data. You can search for it on GeoNode, load it up in a map, or you can access it from QGIS. So let's talk about custom web GIS. So this is an application that we built for our client. And this just allows us to do a lot of basic functions for the client. So things like toggle overlays, it supports WMS, WMTS, WFS, vector tiles, point stacking. So really whatever data we want to load. This usually comes down to the quantity and type of data that the client wants to share. So we have instances where we spin up this map with just vector data. It's fine. But once you get over a certain point, the map starts crawling to a halt. So you might want to actually serve that out as a WMS, so as a tiled image service. We can also have a base map switcher and switch between a variety of different base maps, search and zoom. We can customize this. So this is, again, when you create a custom WebGIS, you can pretty much do whatever you want. So if you want to search specific data sets, you're able to do that. We can identify features like you see on this screenshot where we click on a parcel and you're able to find out information about it. And this map was created basically just to identify whether a property is within the regulated zone of the Conservation Authority or not. You can filter features. You can create a custom print layout. So we do this for users, and printing from WebGIS is always a challenge. So we have a custom print module that we're able to add on to these maps. We're always working on it and trying to improve it, of course. And the GPS tools are nice. If you're a logged in user, you can actually collect points in the field. So if you're walking along and you see a broken fence or something, you're able to, record a point just like that using this map. You can have public and private tools, so you can turn tools on and off depending whether or not you're a logged in user or just a public user. And likewise, you can have layers. So we have a group of private layers that are only available if you're a logged in user to this application. And then with that, if you are going to allow login users, there is going to be, there is login user management. So we can create additional users. And then with more complex applications, we can actually create different roles. So maybe you're somebody who can edit data, or you're somebody who can just see a bunch of data sets, or there's a bunch of sensitive, really private data sets, and you're not allowed to see them unless you're an admin user. And if you're a standard user, you won't see them. So we can be really quite granular with how we work out the permission system within these applications. We can also share your location, so you can share the map and that will load the map with the same layers that you have turned on at the moment you press share. And we also can put some basic tools like measurement tools and other things like this. One of the really nice things about this application is that we can create custom tools. So this is what we typically do for a client, right? Is that they're going to come to us and say, okay, we like all this basic stuff, but we want a tool where if you click on it, it's going to make me a coffee. I don't know if we can do that, but we'll try. Or we can create a custom tool like click on an intersection and put in a radius, and I want to know every parcel within a 5-kilometer radius of this point because we need to notify them about some sort of construction that's going to be taking place at this intersection on such a date. That's easy to do. We can do that. And the list goes on. Really, this is the basis when you're building a custom WebGIS. It really comes down to what the client comes to us with, right? If they want something really specialized, this allows us to do this. We have no restrictions. All right, mobile data collection. Then I do want to get into a little bit more of a demo so I can show you some stuff. MerginMaps is a beautiful thing. If you haven't tried MerginMaps yet, I'll just say you're not living. MerginMaps is a mobile data collection platform. It allows you to do field data collection. And yes, it is, as they say, the easiest way to take your QGIS projects into the field. It's fully integrated within QGIS. It has a plugin. You're able to create projects within QGIS, serve them out to MerginMaps, and the world is a happy place. You can view your data and location on a map. You can capture point lines, areas, and even photos. You can scan barcodes. Yes, you heard me right. You can scan barcodes and QR codes while you're in the field. You can sync data with the press of one button. So there's no like plugging in cables or transferring data to your system and then doing this. You just press the button when you're connected to the internet and you will sync all the changes that you've made to the project to this central cloud-based system. You can store and version your data safely in the cloud. Nice thing about this is that Mergin is based on the amount of data you actually use. So they don't really care how many projects or how many users you're using. So you can create 100 users if you want. But if you're collecting a lot of data, you're basically being charged by the storage amount, right? So that's how their pricing is set up. And with the plugin, you can actually sync your data back to your enterprise PostgIS server. Now, says Enterprise Edition coming soon. That's out now. So we're actually a partner on MerginMaps. So we're an authorized dealer of the Enterprise Edition. The nice thing about this is that when I was chatting with the developers, I was saying that for Canadian, especially municipalities, but any sort of public organization, the data has to reside in Canada. So MerginMaps is developed in Europe. I said, well, that won't work. So using your system will not work for any organization that has to have data within Canada. So what's nice about this is that we're able to spin up the Enterprise Edition on one of our servers for clients. And we do this for a few right now who have actually moved over to the Enterprise Edition. The nice thing about that is that you control how much data you actually want to store locally. So all of a sudden now, the amount of storage you have is really based on the size of your server. So if you want to increase the storage on your server, you can store more. So if you're ever interested in Enterprise, please just reach out to me. I'm happy to give you a little bit of a demo on how that works. All right, demo time. So we're going to configure an open source GIS server with data from Kitchener, Ontario. I went on to the Kitchener GeoHub, and it's really nice, all the open data now, right? I think every government in the country has some sort of open data portal, we hope, and we're able to access a lot. So I went on to the open data portal for Kitchener, Ontario, and we downloaded various vector and raster data sets from Kitchener's GeoHub, and this is the address for Kitchener's GeoHub. And of course, to make the lawyers happy, just so you know, LunaGeo has not received any endorsement, support, or sponsorship from the city of Kitchener with regards to the public data used in any software or service promoted in this webinar, implied or otherwise. We just took the data and we're going to use this to show you how this software works. So migrating vector data, this is a big step, right? So when we're moving a client to open source GIS, this is the thing that we work on the most, is we migrate data to the platform. So we configure the database structure, we figure it out. We load vector data by the database manager. I'll show you how that works. We create default symbology. We create projects within the database. We create trigger functions as needed. And we can then also run spatial SQL with the database manager. So if I flip over to QGIS, the database structure that we put together, I can sort of show you what this would look like in the database manager. So we put together their server right now. We only have a few schemas, but we can create additional ones. It's as simple as sort of going to schema, create a schema, and we can call something like hydrology. And now we have a new hydrology schema. And if we want, we can import data directly into it. But we created a few. We have one called boundaries. And if we expand that, we have the Kitchener boundary and we have the wards as well. What's nice is that when we click on any one of these, we can see all the information about these layers. We can see which fields exist. You can even go through and see a preview. I don't recommend this with a very large data set just because that preview window sometimes freezes, especially if you do something with like a large parcel data set. But that kind of goes without saying. We've created additional ones, so like city services and so on. So everything's now is in the database, and the import layer function is really quite easy. This is the window that you'll see. You'll sort of select the layer, select the schema where you want the layer to be saved, call it something. But what's really nice is this is where the magic happens, right? We can define what the primary key field will be, what the geometry field will be, and here we can define the source and the target. So if you have a source where it's actually not defined, you can define it in here. You can say, yeah, it came to me in EPSG 4326. But you know what? I want it to actually be in something entirely different. I want it to go into the database as 3857, so a pseudo Mercator. And you can do a bunch of different things like replace a destination table. So if you have a layer that you're going to be updating or changing completely over time, you can click this and replace it in the database. You can play with it. If it's a multi-part geometry, you can promote it to multi-part. You can also convert field names to lowercase, which I always click that because I like all my field names and table names to be lowercase. And we can also create the spatial index. Okay, so we've loaded all of our data into the database. We can access it through the browser panel here, which is the easiest way. We just simply create a database connection, and we can load our layers. So you saw that I already styled the ward boundaries. We can easily load those from the database. All the data in here is in 4326. That's how it was provided. We could have changed it to UTM 17 North if we wanted to, but this is fine for now. And again, we can add the boundary to the city. We can add any of these layers. Now you notice that when the layer comes in, it's coming in with a default symbology. And that's because I actually established these symbols and save them as default. So when we go into the properties for one of these layers, we can see that we have created a sort of simple line. And we can save these as default. So if you save it as default, you get prompted with this window and it says, save it to the data source database. Really handy tool, because now all of a sudden we are saving a default style to the database. So if I've decided that, oh, you know what, I don't want this to be this color, I want this to be green. Okay, so now the ward boundaries are green. We can save an additional style. So we can save style. Now we don't want it to be default. We just want it to be in the database in case we ever want to use the green style. So I'm going to call this wards green. And I'm just going to press save. So this saves it within the database. I'll tell you where. In the public schema, there's a table here called layer styles. This just takes the SLD for that layer and saves it directly in the database, and it's accessible. So now if I was actually going to create like a new project right now and come back and load the ward boundaries, oh look, they're still orange, of course, because that's the default symbology. But if I go into the properties for this layer and want to load an additional style and I select from the database, you can see now that we have two options. We have this one, which is our default, but we also have the wards green. I can load this style and press OK, and now we're back to having the green one. So what's nice about this is that A, you can save multiple styles in the database. You can save a default style, but B, you can control who has access to this styles table. So through permissions within the database, you can say, you know what, only admins are able to create, update, change styles. Everybody else has to use the styles as they're loaded. Now, this, of course, doesn't prevent you from changing the style once you load the layer. That can always happen. It's vector data, do what you want. But you can't save those changes to the database. So it allows you to have that integrity within your enterprise environment. Okay, so the other nice thing that we can do, we can just ignore this little project that we've created here, is we can save projects directly within the database. So I created this like Parks and Rec project, and I saved it directly within the database. So as it loads, I've loaded a whole bunch of vector data that's being pulled directly from the database for all the various parks, baseball diamonds, and everything within the database. And here we are, we're using an OSM data set, but we can also use, you can flip this to use one of their aerial photos. So this is their 29 aerial. And again, this is all being served directly from Geoserver. So of course we can turn off everything, we can turn off all the vector data. We can zoom in specific layers, anything you normally do within a GIS, you're able to do this. But the neat part about this is the project itself is being saved within the database. It's actually being saved within this file here, or sorry, this table here called QGIS_projects. This is where all of your projects get saved in that schema, the Parks and Rec schema. What's nice about that, again, it's a database object. So what can we do? We can enforce permissions. We can say only certain users have access to these projects. Only certain users can save projects within this schema. So in other words, they won't be able to modify them, right? These are going to be quite secure within the DB. All right, so the next thing we can do is spatial SQL functions. So once we load all these data within the database, we can do a whole bunch of fun stuff. We can ask questions like, how many playgrounds are there in each ward in Kitchener? And I teach a course on spatial SQL. It's one of the ones that I like teaching the most. because I find that once I teach this to somebody, especially somebody who knows GIS already, all of a sudden they start doing a lot of their work within the database and stop creating all that annoying intermediate data. So this is a basics intersect. So again, this is one of the functions, st intersects, that basically just runs an intersect between the two geometries. And I've done a few little things where I've casted the ward number. It's actually a bar chart, and I cast it to an integer just so I could put things in order. So when we run this within QGIS, we end up with the results. So this is the query that I ran within the DB manager, and we end up with a count for the number of playgrounds within each ward within the city. So it looks like Ward 5 needs more. What's nice about this too is you can save these queries, you can rerun them. So I remember when I was working at one of the Kettle Creek Conservation Authority years and years ago, we did their watershed report card. And I was able to just do it all in SQL. So all of the data that we need to pump out for this, I was able to write one big long SQL statement, press go. I think it took maybe a minute and a half. And it pumped out the results. It was just a table of values that we needed for the report. So in other words, if there's something you're going to have to do and redo over time, turn it into a SQL statement, run it, it's done. Tell your boss it took you a long time. All right, migrating raster data. So the process of doing this, I already showed you the images as we loaded them, but we can optimize the raster data using GDAL. We can serve and cache the imagery with Geoserver and GeoWebcache, and we can consume web services via QGIS. So we did this for their 2016 and 2019 aerials. We took down, I think they're in like SID format or something like that, and I just converted them to GeoTIFF, fully optimized them, loaded them into Geoserver, and let's just make sure we're still logged in. So here we're in Geoserver, and we loaded a bunch of layers, and if we go into, I have all my demo data that I have in here. So if I filter by KW, we can see that we have two layers. We have the 2016 and 2019 aerials. We can see a preview of these. We can zoom in and see this is what it's going to look like. And again, the 2019 imagery can also be loaded. So this is being loaded as a single GeoTIFF. And then it's being loaded as, in this case, as a WMS service. So what else can we do? One of the nice things about Geoserver is that it includes a caching service called GeoWebcache. So what we're able to do is cache the service. So you can see I've only done a little bit, and I always like doing this during a demo because I don't like showing a very unrealistic demo. I could have seeded all of this imagery and had it loaded super fast, but I didn't do that. So I just loaded it, and I said what you can do over time is sort of add to the cache, right? So if there's areas in the image that you're going to be going to quite a bit, you're going to build those tiles. You can, of course, seed the whole image if you have this disk space to do that. But this is a nice way of doing it. So if I was to, let's say, turn this off and zoom into a specific playground, here I am at a specific playground with the 2016 imagery, and I can flip over to the 2019 imagery. These tiles were actually created already. So they don't, so they're being pulled from the cache within the server. They're quite fast. And again, I can flip over to another park, and these tiles, of course, are coming directly from the server. So if we go back to Geoserver and I was to refresh right now, we're not really seeing any change in terms of the number of the disk space. But if I start panning around, you can see that there's thinking. There's thinking going on. And I have a very large screen. I have a 32-inch monitor. So I'm loading a lot of tiles within each screen. So if I'm doing this, and right now I'm on the 2019 imagery, and I come back to Geoserver and I press refresh, you can see 2019 went up now to 209 megabytes of cache that we're storing for that layer. So all those tiles that I generated as I did this, just panning around, and again, let a few more load, and then flip back over to Geoserver, refresh, and we can see we're up to 225. So we're generating the cache on the fly, which is a nice way of doing it, because then those areas that you go to quite often are going to be quite zippy, and those areas that you don't go to, well, there's going to be no cache built for those. Okay, that's aerial photos in a nutshell on how we set this up. So I wanted to show you how to use MerginMaps. I realize we're coming close to the top of the hour, so I'll kind of make this fast, but I might go just a little bit over if you're interested. I wanted to create a playground inspection app with MerginMaps. So the first step is really loading the data. So there's 318 playgrounds in Kitchener, Ontario. I converted the playground polygons to points. That's just to make it easier on the app because we really just need a point. We need the centroid. And I saved it out to a geo package format. I created a project with OSM, the playground points, and the city boundary, which you can see on the map to the right. And then I found this playground equipment daily weekly inspection from the Canadian Playground Safety Institute. It sounded authoritative, so I used it. So step 2, I wanted to create this daily weekly playground inspection fields. So I found this report. I converted the daily paper form into a QGIS attribute form that contains playground location, inspector name, inspection date, time, and then 8 main questions, followed by 3 text fields for comments and notes. So not very complicated, but I created these additional fields within the original playground data set. So we have our date time field, we have some text fields just for the inspectors' names, and then we have a bunch of medium integers. These are just a data format for GeoPackage, and then we have the 3 text fields at the end. So here's where it gets fun. I create an attribute form, and if you've never created an attribute form within QGIS, again, you haven't lived. You can create very complex forms that can have conditional logic. You can have it be that if you click this, something will show up. But I wanted to create a fairly straightforward one where we had 2 tabs. So we have a tab for the inspection, and we have a tab for all the attributes that are associated with that data. So I think there's like 20 or 25, but we don't need to see those. We just need them available in case the inspector, for some reason, wants to find more information out about this park. Like there was supposed to be a swing set, but now there's no swing set. And I also added aliases for the questions to make the form easier to understand. So I actually shortened these a bit from this screenshot. So I had to shorten them a little bit just to work nicely with MerginMaps. And I added widgets for drop-down menus. So for the drop-down menus, we can select satisfactory, not applicable, or unsatisfactory. And I also added the date time one up here to allow us to select the date and the time. Now, step 3 is create the MerginMaps project. So I had to package the project for MerginMaps using the MerginMap extension. It's really quite easy as that it exists right here. It allows you to simply press this button. I don't want to do it in this project, but it allows us to sort of create a new project or save an existing project to MerginMaps. And I did a sync of the application to MerginMaps, and then I could sync it to mobile, and then survey, and the world is a happy place, and we collect a whole bunch of data. So this is a screen that you see. You can package the current GIS project. That's typically what I do when I'm creating a new project with MerginMaps. And then I can select which layers, and I want to package up the municipal boundaries as well as the playground layer, and I want to keep as is the OpenStreetMap. So I'm still going to call OpenStreetMap when I'm out in the field. I wanted to say where I want to save this. So I was saving this on my own local file system just to identify where I want to save it. And then I'm going to create the Mergin project. So this is now saving the project to the cloud. Once we do that, we're able to load the project within the app. And on the right, you're seeing the Android app, and you're able to see the exact same points and the exact same features. And we have inspection points where the inspection is incomplete. Those are red, and where they're green, those are playgrounds where the inspection is complete. The form looks identical in a sense. It does the exact same thing, where on the left, and you can see I've sort of shortened some of the text here. We have all 8 questions and the drop-down menus as well as the text fields. And then on the right, we can edit the features, right? So we can edit them, make any changes. You have the same drop-down, same date pickers and so on. So the nice thing about this is whatever form you create in QGIS, you're going to have the exact same form available to you within MerginMaps on the app. So QGIS is really the central app where you're building all of this stuff. This is where it gets really interesting, is that as we're collecting data, and I'll show you actually, let me show you quickly how this loads. I have a second. I can't see your faces, but I know you're interested. So I could load this QGIS project. No, I don't want to save this. Go away. So I have this project loaded right now. I can go in if I want and identify any one of these points right now, and I can change it to being whatever, like I can edit these individual points. Oh, sorry, I'm on the wrong layer. This one. This makes a lot more sense. Okay, so here's our form, right? We have our drop down. I could say satisfactory, satisfactory. I'm very satisfied with all of this. And make our change. We can select the date. We can select today's date. We can select my name. This could be a drop down also. It could be a related table if you want. And we can press save on this. And if I've made some sort of change now, and you can see it turns green now that I've applied a date to it, that's how I set this up. I can press sync now, and sync is going to pop up for MerginMaps. I've made one update, it says, and I can make this change, and now this change is going to happen. And then anybody using the app, I can't show you the mobile side right now, is going to be able to press sync and see that change that I just made. So this is where it gets interesting. MerginMaps also saves a history of all of your changes. So if you're going to do your playground inspection and then you realize that you hired some summer student to do something and they kind of screwed up and some of the data they messed up, and you know that everything since 33 minutes ago is complete garbage, you can actually restore this version 3 and say, you know what, that's the good data set. We don't want anything after that. So another nice thing we can do here, there's a lot more to it than this, and I'll be doing a webinar soon, probably in the next month or so, on MerginMaps and show you some of the more advanced features here, but you can clone projects. So if it's something like this, I don't think you'd be doing such an extensive survey on a daily basis on playgrounds unless you have a lot of staff. But let's say you're going to be doing this monthly. You can actually clone this project and make a copy of it. So create it, don't edit anything, and then have that be your template, and then clone that template every time you want to run a survey. Then within MerginMaps, you're going to have a survey for every month. You can even create the whole year ahead of time, have all 12 months ready, and then somebody can just log in and say, you know what, we're doing the December one now, let's do it. It's a really great feature. And again, I'll be talking a lot more about MerginMaps in the coming months with a few different webinars. Okay, so if any of this is interesting to you, we do have a current GIS server trial offer for anybody who participates in this webinar. So what we wanted to do, and I always say this, I'm like, well, you can hear about this stuff, but unless you actually try it, it's really hard for you to evaluate if this is the right solution for your organization. So what we're offering is 3 months. 3 months is a good amount of time. We get to interact a lot. We get to try stuff, fiddle with a bunch of different software. So we're knocking 50% off for the server fees for 3 months. We do a basic implementation, so you can hand us a whack of shape files and some aerial photos. We'll optimize those and throw them up on your server. We're going to do 3 private group training sessions at 50% off, so that's all incorporated into the price. So we can do, we'll customize that, right? So if all your users are fairly advanced, maybe we'll do a lot on like spatial SQL and Geoserver. If your users are very basic, we might start with like some intro to QGIS and then QGIS and PostGIS in an enterprise environment, and maybe stay away from the more sysadmin stuff. So we'll, tailor that to your needs. The nice thing is we do Q&A. Every week we'll have a set half-hour meeting. We'll get together. We'll talk about what you've been doing, any problems that you might have had, and we'll go through it. And we're also offering, in addition to that, we'll offer you 10 hours of support during the trial period. That allows you to submit a ticket, get an answer. If you're like, how do I do this? Or I want to create a workflow to do this, we can help you out with those problems just to keep you going and give you the chance to fully experience this software firsthand. So if you're interested, get in touch with us. The promotion code is spring 2023, and you can just navigate over to lunageo.com/servers or just email contact@lunageo.com, and we will be more than happy to get you set up with a server. So I've gone over time by only 4 minutes. That's amazing. I thought it was going to be a lot longer than that. If there's any other questions, drop them in the Q&A. Somebody did send me a private message and asked, what happens after the trial period? Well, we lock you in for life. No, I'm just joking. After the trial period, we basically give you the option. You have a couple of different options. You can either just cancel completely. We shut down your server. We part ways. That's fine. We can spin you up on an annual contract if you're interested in just diving right in, and then we'll fully implement your GIS server. If there's more data to load, we can work out a contract for that. It'll be something completely separate. Or you can continue on a monthly basis and we'll just give you a regular monthly price. You can keep on using it. So we had a number of clients to do this. They sort of try out with a trial, give it a go, and then they move on to say, you know what, we want a few more months to sort of fiddle with this because we're quite busy. So we keep it going for a few more months, and then they eventually, move into an annual license, which saves you like 2 months per year. So it's usually best to go for the annual license. So yeah, after that, it doesn't roll over into a fee. So you're not going to randomly get an invoice in the mail for, a year's worth of service or anything like that. John, nice to see you, at least in text form. Is GeoNode a replacement for GeoCortex? Now that's a loaded question. I can say this about GeoNode. It's a very powerful application. It's a young application though. There are still things that are being developed within it. It is not nearly as close to the maturity as something like QGIS or Geoserver. But I have to say that I've been monitoring it since about version 2. Version 4 is great. There's a lot of really powerful features in it. I think that definitely it's a replacement for anybody who has a GIS portal online. And if they want to migrate to an open source GIS solution just to share geospatial data in order to have some sort of web cartography out there, definitely you can use it for this. And this is what it's meant for. You don't need to use all the features, things like geostories and all that. You can sort of turn those off and have a custom deployment just for what you need. But definitely it's there. I have clients who use it and love it. I have clients who do collaborative mapping on the web with their clients, and they really enjoy it. So it's a powerful tool. So watch for a webinar. I'm thinking of doing it, if I feel ambitious enough, maybe in May, maybe in June, but I want to build, what I'm probably going to do is build a GeoNode application, and I'm going to take all the information I can, get from one municipality, let's say, and load it up onto GeoNode, and we'll see how it looks. So I'll sort of replicate an existing portal they have within GeoNode. So that's kind of what I'm thinking, but don't hold me to it. All right, if there's no more questions, thank you all for coming. I will be sharing this video with you afterwards. So if there's anything you want to go over, once I have it up on our YouTube channel, we'll be sending you an email. So you'll be able to, relive the magic, as we like to say. Thanks a lot, everyone, for coming.